In this video, we're going to be talking about direct and inverse variation. So we're going to let k be a non-zero constant real number. So the statement on the left are equivalent to the equations on the right. So here we have y varying directly as x, or something that says y is directly proportional to x. And in this situation, we are going to notice that we're going to have k being multiplied by our x. In the second set of statements, we see that it says y varies inversely as x, or y is inversely proportional to x. And in this situation, we see that our k value is being divided by our x. So note that k is called the constant of variation. So directly would be the k is being multiplied by x, and inversely, the k is being divided by x. Now, an example of direct variation would be, direct variation. Suppose that a car is traveling at a constant rate of 60 miles an hour. So there's our constant rate, or in other words, there is our k value, and it's at 60 miles per hour. So then the distance that the car travels would be d equals 60 times t, which is a direct variation. Now, an example of inverse variation would be, suppose that there is a set distance that a car is traveling, let's say 240 miles, right? So that's our set distance the car is traveling. That is our k. Then the time it would take to travel would be that t equals 240 divided by r, and would depend on the rate the car is traveling, which is an inverse variation. Let's try some examples. So we're going to write a variation model using k as the constant of variation. For A, it says the amount of medicine A prescribed by a physician varies directly as the weight of the patient. So directly, so that tells us that we're going to be multiplying. It tells us that we're using A, and the medicine prescribed is going to be multiplied directly. So we're going to have our k value being multiplied by our w. And I should be careful that make sure we're making our lowercase k times w. Now problem B says the frequency f in a vibrating string is inversely proportional to the length L of the string. So in this situation, we're going to have f equals, and because it's inversely, we know that we are dividing. So our k will go on the top, and our length of the string will be what goes on the bottom. And then one last example, we have the variable y varies directly as the square of x and inversely as the square root of z. So here we're doing two things. Now we know that we're going to have a y, and we know that our k value varies directly with our square of x. So there's our k, and our square of x would be x squared, so k times x squared. So there's our multiplication, and then it says and inversely, so dividing by, and it says the square root of z, so square root of z. And so that's how you would set those problems up if you had a direct proportion or inversely proportional, or something that even was directly and then inversely related or variation to that constant. Notice though that each time, in each variation, the constant of variation, the k value, is always in the numerator. And that's a good little something to remember as well to help you when you're setting up your models.